What up, guys? Welcome to the video on the quadratic formula, or using the quadratic formula. We start with a do now, just like in the classroom. We listed the 5 steps for completing the square. If you guys don't remember that, look at the video for completing the square. And part B is to simplify 1/2 over 2. Another way to think about this is as 1/2 divided by 2. So if we recall, anytime we have a fraction and we're dividing by a fraction, we actually multiply by its reciprocal. So this does have a 1 under it, or a lazy 1. That is the same as saying 1/2 times its reciprocal would be 1/2, which just gives us 1/4 for 1 over 4. So this would be our answer, and this again, it just comes from Algebra 1 or arithmetic. It's just a little bit of review. This is the quadratic formula, and not so much of the discriminant in this lesson. For that, look at the video for discriminants. We're going to go ahead and kind of talk about the quadratic formula. It is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, there's a lot of cool ways to remember that. There's a Pop Goes the Weasel song, rap songs that we've listened to in class. And in particular, my favorite story, it's the negative boy was undecided to, the negative boy was undecided to attend the radical party, and where the squared bouncer took away 4 alcoholic containers, the party was all over 2A, leave off the M. So there's multiple ways for us to kind of memorize the quadratic formula. Whatever works for you, do it. Now for the quadratic formula, we've studied 3 other ways for solving roots or solving zeros. The first method that we covered was solving by square roots. So by square roots. The second method we covered was by factoring. The third method we covered was by completing the squares. Complete the square. And then this third or fourth method is the quadratic formula. In class, we actually used all 5 steps to prove the quadratic formula. We started from our standard form of a quadratic equation, and we ended up with our quadratic formula. In this video, I will not prove it. I might post one later on for you guys, just so you guys can see the proof and understand how we derive this quadratic formula. So let's go ahead and go straight into step 1. It says use the quadratic formula to solve. So I'm given the standard form. Now in the standard form, there's one thing that's not right. This is not set equal to 0, which means we have to set it equal to 0. Let's go ahead and write this as a plus 5 or add 5 to both sides. Actually, what we're doing is we're balancing our equation. When we do this, on my right hand side, we're left with negative x squared plus 4x plus 5 is equal to, and on my right hand side, these two are equal to 0, so we're left with that 0. Now we have our standard form. In our standard form, we know we have an a, b, and a c. So let's go ahead and write those values down. Our a is going to be negative 1, b is 4, and c is 5. Once we have our values down, we're going to apply or substitute directly into our quadratic formula. And just in case if we forgot what that looks like, it's x is equal to, remember x is our root or our roots, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and substitute directly into this formula. We get x is equal to negative, my b value is 4, plus or minus the square root of our value b squared minus 4ac all over 2a. So what I'm actually going to do is I'm going to color code this so you see where all my values come from. So I left just the shell of my quadratic formula, and then I'm going to plug in directly. So b is going to be 4, plus or minus, again, b is 4, minus 4a, so my value a is first, that's going to be negative 1, and then according to this, c is my next value, that's 5, and a is my last value, that's negative 1. So we just filled in or plugged in directly into our quadratic formula, and then we start simplifying things out. I like to work with what's inside our radical first. It's also known as our discriminant, and you'll see that in the next video. So let's go ahead and work with that first. We distribute the -4, or the negative into the 4, plus or minus, and we get 4 squared, it's just 16, and we get -4 times -1, that's plus 4 times a 5, all over -2. I'm going to bring all this work up here so we can continue working on it. We're going to work inside the radical again, so now we get 4 times 5, well, that's a 20. So let's go ahead and simplify this just a little bit further. We get -4 plus or minus the square root of 16 plus 20, again, all over -2. We keep simplifying. -4 plus or minus the square root of 36, that worked out fine, all over -2. Now we know what the square root of 36 is. The square root of 36 is actually just 6. So really what we're left with is this -4 plus or minus 6 all over -2. Now this plus or minus, remember that that's two answers. So that really means x is equal to -4, and we'll do the plus first, plus 6 over 2, or -4 minus 6 over -2. Oh, and I forgot the negative here. So if we solve for both of those, we should get our roots. So my last line should be -4 plus 6, or yeah, -4 plus 6 is just 2 over -2, which we get -1. And we're going to add the opposite here. We get -10 over -2, which is +5. So my two roots actually come up to be -1 and +5. That's our very first example. So again, guys, you guys can pause and review as much as you need at your own pace. This is totally just for you guys. These are your notes. Let's move on to the next example. In class, we kind of went through three different levels of difficulty. We went to a kind of a beginning level, intermediate, and an advanced level. For this video's sake, let's go, or actually, let's work on the green one and see what it looks like to have a leading coefficient and what that might look like. So again, this is already set up for us in standard form. We need to find out what our A value is, that's 2. Our B value is 2, and our C value is -7. If we substitute directly into our formula again, so we get x is equal to -b plus or minus square root of b squared minus 4ac all over 2a. We're going to plug in directly into that. Let me write to my shell so we can see how we did it last time. Negative some b value plus or minus the square root of some b value squared minus 4 an a value, a c value, all over 2 and some a value. So if we substitute our values into our quadratic formula, our b value is 2, our b value is 2, our a value is 2, and our c value is -7. My a value is 2. I'm going to go ahead and clean that up and just simplify. And again, I like to start with whatever's in my radical, also known as my discriminant. We get -2 plus or minus the square root of 4, and then -4 times 2 is -8, and then -8 times -7 gives me a 56, or +56, +56 all over 4. So 56 plus 4 is 60. We're going to go ahead and add those up. We get -2 plus or minus the square root of 60 divided by 4. This actually, the 60, I believe you can factor it out. There is a perfect squared that goes into that. So 60 by 4 should work. Yeah, 4 works perfectly. So we're going to go ahead and factor the 60 out. And this is actually going to give us negative 2 plus or minus the square root of 4 times the square root of 15 all over 4. And again, all I did here is show you guys that product property rule that we learned from the previous lessons. So we're going to go ahead and simplify this. We know what the square root of 4 is. That's just 2. So what we are left with is negative 2 plus or minus 2 root 15 all over 4. This can still be simplified just a little bit further. We notice that both in my numerator's case, there's a 2 we can factor out. If we factor out a 2 in my numerator, we're just left with negative 1 plus or minus 1 times the square root of 15. And in my denominator, we're left with 4. Well, 2 and 4, you can actually cancel those out because you can divide both the numerator and the denominator by 2. When we divide the numerator by 2, we get a 1, and in the denominator, we get a 2. My final answer being, let's see if I can squeeze it in, is negative 1 plus or minus the square root of 15 all over 2. All right. So just in case you guys need to see that as 2 answers, I'm going to write it right here. That should be negative 1 plus the square root of 15 over 2 and negative 1 minus the square root of 15 all over 2. Cool. So I hope that kind of helped out, guys. And the very last thing we have is a very tricky one. It's 3 examples. Let's go ahead and write this into a standard form. We get 25 x squared, or actually, I'm getting ahead of myself. Let's go ahead and subtract 12x from both sides. Subtract 12x from both sides. This goes away. I get 25 x squared minus, I get 30 x and is equal to negative 9. I'm going to add 9 to both sides. Add 9 to both sides. I'm going to get 25x squared minus 30x plus 9 is equal to 0. Alright, when we get this, guys, we can actually see if there's anything we can divide by on all 3 of these. So in this case, unfortunately, there is not. So we're going to go ahead and list our A value, our B value, and C value. Our A value is 25, our B value is negative 30, and our C value is 9. Awesome. Let's go ahead and plug into our quadratic formula. I'm going to get, so again, if we don't know what that is, I'm going to write this one more time, negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go, just like the song. All right, so we're going to get negative, not 25, let me correct that. We're going to get negative, my b value is going to be negative itself, so negative 30. Plus or minus the square root of my b squared, that's negative 30 squared, minus 4, my a value is 25, and my c value is 9, over 2 times the quantity of my a value, that is 25. So let's go ahead and start again with my discriminant, or whatever's inside my radical. I'm going to distribute these bad boys out. Negative times a negative is a positive. Plus or minus, well, the square root of negative 30 squared is 900. Cool. Negative 4 times 25 is negative 100. Negative 100 times 9 is 900. Awesome. And in the bottom, I get 50. Well, the beautiful thing about this is that 900 minus 900, that goes away to 0. So what I am left with is 30 over 50. Which just reduces to 3 over 5. And we just have one root in this case. Cool. So hopefully, guys, this helped you guys out a bit. I kept it under 16 minutes, which was pretty good. Cool. If there's any questions, please ask me in class. I'm here to help you guys. Hope this helped. Bye.